Good morning. Good morning, students. So, chemical bonding and molecular structure. Okay. So, good morning. Very good morning. So, can anyone tell me what we have discussed in Saturday's class? Any one of you? What we have discussed in Saturday's class? Lewis dot structure. Very good. So we have discussed about Lewis dot structure. Yes, very good. When I am talking about Lewis dot structure, it's going to give the information. Yes, Shuchita, it is related to bonding in a molecule. Yes. So when I am talking about Lewis dot structure, it gives the information about types of bonding. Okay, it gives the information about types of bonding. Okay, so that's where Lewis dot structure comes into the picture. Now, for example, if I take water, right? Now, how to write the Lewis dot structure for water? It can be written as 1, 2, 3, 4, right? So, hydrogen, hydrogen. That's where we have hydrogen, and that's where we have the oxygen. So, this is the Lewis dot structure for water. So, single covalent bond or single bond is present between oxygen and hydrogen in case of the water. Now, when it comes to carbon dioxide, generally we will write like this. This is the general structure. But if I go with Lewis dot structure, that's where I can write it as oxygen 1, 2, 3, 4, 3, 4. So that's where we have the oxygen, and that's where we have the carbon. So this is with respect to carbon dioxide, right? That is for the carbon dioxide, Lewis dot structure. Okay, extreme right one. Now, all of us we know that with respect to carbon dioxide, it is having double covalent bond. So, with respect to water, it is single covalent bond. Okay, and with respect to carbon dioxide, it is double covalent bond. Okay, so this is one condition. So this is second condition. Now we will go with another one. Okay, we will go with the another one where we are talking about nitrogen. So when I am talking about general structure, we will write it like this for nitrogen, right? Now if I want to write the Lewis dot structure, 1, 2, 3, 4, 5. 1, 2, 3, then another nitrogen. So each will be having 8 electrons. So that's where we have the Lewis dot structure. So now here we can call it as triple covalent bond. Triple covalent bond or triple bond, that is fine. So single bond, double bond and triple bond, that is also fine. So hagadre when it comes to single bond, the only 2 electrons are involved. When it comes to double bond, 4 electrons are involved. So when it comes to triple bond, we have the 6 electrons which will be involved in the bond formation. Okay. So hagadre what do you mean by double bond? So double bond is a covalent linkage where two electrons are involved, and a double bond is the one where 4 electrons are involved, and triple bond is the one where 6 electrons are involved. Okay, all of you have understood? All these things are related to covalent bond only. So depending on the number of electrons involved, so we have different types: single, double and triple. Fine, all of you have understood? So whether covalent bond is a strong bond or a weak bond, any one of you, whether a covalent bond is a strong bond or a weak bond. You can just mention strong or weak. Whether covalent bond is a strong bond or a weak bond. Anyone? Yes, all of you have given. Okay, Rohan, Shuchita, why covalent bond will be a weak bond? It is a strong bond. Covalent bond is a strong bond. Yesterday, we have taken the example of water. If I boil the water, still we have the water which will be intact. That means OH bond will not be cleaved. It should be a strong bond. So Rohan, I am not comparing with any other interaction. As an individual I am talking about. Okay. So anyway, metallic bond, ionic bond and all we are going to discuss. Especially ionic bond is there. Okay. So that's where, yes Shuchita, due to the sharing of electron, covalent bond will be formed and it will be a bit stronger bond. Okay. So don't worry, we are not comparing between different bonds. But as a covalent bond, yes, it is a bit stronger interaction. Okay. So which is due to the sharing of electron. Yes, absolutely correct, Pooja. Okay. So all of you have understood. So that's what we have discussed. Hagadre, when it comes to Lewis symbol and Lewis dot structure, they will give the information about number of covalent number of valence electron, and they will give the information about type of bonding. They will give the information about type of bonding. So when it comes to Lewis symbol and when it comes to Lewis dot structure, okay, so now based on these we can find out what is the total number of valence electrons in a atom. Okay, total number of valence electrons in a atom. Then that is one information we are going to get, especially with respect to Lewis symbol. That's what information we are going to get, which is that what is the exact number of valence electrons in a atom or a element. So that is one thing. So what is that next one? Next one is especially with respect to Lewis dot structure. Types of bonding. Types of bonding in a molecule. Types of bonding in a molecule. Types of bonding in the sense whether it is single, whether it is double or whether it is triple. So that's what we are going to get the information with respect to Lewis dot structure. All of you have understood? Then it will give the information about number of I think I can give the information number of lone pairs of electrons. That means which are not involved in the bonding. Which is not involved in the bonding. It will give the information about number of lone pairs of electrons which will be left over after the bond formation. That's where we have the lone pairs of electrons. Okay? Or we can get the information about free electrons. Number of free electrons which are not involved in the bonding. if at all it is left over. It's not compulsory that in a molecule all the atoms should be having free electrons. No, it depends. Okay. Say for example, in case of the water, hydrogen, no more electrons left over. Whatever one electron was there, it is involved in the bonding. Okay. If it is left over, what is that total number of free electrons which are left over? That's what the information given by Lewis symbol and Lewis dot structure. So Lewis symbol is applicable for an atom or an element, but when it comes to Lewis dot structure, it's applicable for the molecules. Okay, so all of you have understood. Any doubts in this? Okay, shall we move to the next one then? Okay. So ಹಾಗಾದ್ರೆ I should not remove. Okay, I will keep Lewis dot structure. What are the limitations, or what is that information which is not given by the Lewis dot structure? What is the drawback? So we are going to discuss about limitations or drawbacks. Limitations of Lewis dot structure. Okay, what is that information? It's not giving. It's not discussing about the shape of the molecule. It will not discuss about the shape of the molecule. Okay, so that's very important. That is the major drawback of Lewis dot structure. It does not talk about shape of the molecule. That's where we have another different theory which talks about shape of the molecules. Okay, now next, what is the another drawback of Lewis dot structure? It does not talk about distribution of electrons in a molecule. It does not talks about. Yes, Dikshit, good morning. So anyway, good morning to everyone. Okay, because some of have joined later, right? So that's why distribution of electrons in a molecule will also not be discussed by Lewis dot structure. Very important one is it does not talks about shape of the molecule, whether a molecule is having tetrahedral structure, pyramidal structure, bent shape. So all those information is not given by the Lewis dot structure. That is the major drawback or limitations of Lewis dot structure. Okay, so what is that next? Next one is how the electrons, for example, whatever electrons are shared, how those electrons are present, whether they are exactly present in the center of two element, or they are present little towards one element, or they are away from the another element. All this information is not given by the Lewis dot structure. All of you have understood? Any doubts? So very important one is it will not give the shape of the molecule, and then it will not give the distribution, how the electrons are distributed around the element or atom in a molecule. All of you have understood? So that's where we have the major limitations, or even we can tell how exactly bonding has been done. Even that information is not given by Lewis dot structure, which will be further explained by hybridization and all. Okay, any doubt? So that's where we have the limitations of Lewis dot structure. Okay, in the same way, another point you can mention that it is based on octet rule. Lewis dot structure is based on octet rule, but in reality there is a limitations for octet rule. There is a limitations for octet rule. Limitations for octet rule. Okay, So I will mention this one as bit important. Okay. So limitations of octet rule or limitations for octet. Now, okay, fine. So that's where Lewis dot structure, another disadvantage or limitation. Why? It is based on the octet rule. Lewis dot structure is based on the octet rule. That's where we have the limitations for octet rule itself. Fine. So what is that limitation? Okay, what is that limitations? That limitation is first one. We have some of the elements which are existing or molecules with limiting octets are existing. So what do you mean by limiting octets, or I can call it as incomplete octets? That is better word. I can call it as incomplete octets. Incomplete octets are existing. So what I mean to tell is, what do you mean by incomplete? Incomplete means they have not reached to 8 electrons, but still molecules are existing. Still the molecules are existing. Say for example, I have a molecule called as lithium chloride. So what is the total valence electron of lithium? Any one of you? What is the total valence electron present in the lithium? Just give me the number. Yes, Prithvi, 3 times. Okay, good morning. Yes, it is 1. Yes, lithium is having 1 valence electron. Okay. Now, what about chlorine? All of you correct. What about chlorine? How many valence electrons in chlorine? Lithium, yes, 1. Yes, Chitwan, it will be 7. With respect to chlorine, it will be 7. 1, 2, 3, 4, 5, 6, 7. Fine. So that's where, yes, all of you are correct. It is 7 electrons. So therefore, Lewis dot structure for lithium chloride will be, so this is where we have the Lewis dot structure. If you observe it carefully, we have a condition where after the bond formation, lithium is with 2 electrons and only chlorine is the one which is with 8 electrons. After the bond formation, lithium is having only 2 electrons, but chlorine is having 8 electrons. I am talking about in their valence shell. Okay, so that's where incomplete octet. That is because lithium still it has not gained the 8 electrons, but still this molecule is stable. Lithium chloride exists in the nature. Same way we can take the example of hydrogen molecule, or we can take the example of hydrogen gas. So what is the total valence electron? That is only 1, because for hydrogen it is only 1 electron. Okay, so that's what, Rohan, when it comes to these molecules, it's not going with octet theory. Duplet rule fine, but it's not going with octet rule. So that's where we have the hydrogen molecule. Okay, so both of them, they are going with the 2 electrons. Even we can take the help of boron chloride. So what is boron chloride? How many valence electron in case of the boron? Any one of you? How many valence electron with respect to boron? How many valence electron with respect to boron? Yes, Shuchita, very good. So that's where boron will be having 3 valence electron. Okay. Now all of us we know that chlorine will be having 1 valence electron. Chlorine will be having 1 valence electron, and boron chloride formula will be BCl3. Formula will be BCl3. Okay, boron trichloride. So that's where we have boron with 1 chlorine, boron with another chlorine, and boron with another chlorine. Total 3 chlorine. So like that. Okay. Now if I observe it carefully, this is the Lewis dot structure for BCl3. So chlorine with 8 electron, chlorine with 8 electron, chlorine with 8 electron, but boron is with 6 electrons. Boron is with 6 electrons. So 1, 2, 3, 4, 5, 6. So boron is having only 6 electrons. That's where Rohan, even not going with duplet rule also. Rohan, yes, right? So it is having 6 electrons. But BCl3 is also stable molecule. It is existing in the nature. All of you have understood? Even this molecule exists in the nature. So that's where one of the or many of the examples for molecules with incomplete octets. Molecules with incomplete octets. Now what I mean to tell here is we have group 1, group 2 and group 13 elements which belongs to period 1 and 2. They will form incomplete octet compounds. So which are those elements? Group 1 and group 2. That is alkali metal, alkaline earth metals. So group 13, that is boron family. So in those elements, period 1 and period 2, naturally group 13, P block, it is having from period 2. But group 1 and 2, they are having period 1 and period 2 in their structure. Especially period group 1 will be having 1 in that particular group. Okay. So that's why period 1 and 2 elements of group 1, 2 and 13, they will form limiting octet type of compounds. So please remember, I am not giving this statement, listen to me carefully. I am not telling that elements of group 1, group 2 and group 13, they are forming incomplete octet. No. I am making a specification. I am telling that group 1, group 2 and group 13 element which belongs to either period 1 or period 2. Only those elements I am talking about. Please remember. Okay. So that's where those elements will form incomplete octet molecules. And they are stable molecules. All of you have understood? Any doubts in this? Now if I observe lithium group 1 period 2, hydrogen group 1 period 1, boron group 13 period 2. Okay, so all of you have understood. So that's what I wanted to tell here, that so those molecules which will be having incomplete octets and they are stable molecules, so these molecules can be due to group 1, group 2 or group 13. Those elements which belongs to period 1 or period 2, they are going to form this type of compound and they are stable. Okay. So all of you have understood? Okay. Yes, Vasanta, good morning. Okay, fine. So in that case, this is one thing, one of the limitations of octet rule. What is that limitation? Octet rule tells that a molecule is going to form element is going to form a compound or a molecule to reach the octet state, to have the stability. And now, here we are seeing many of the examples which will not have the octet state, but still those molecules are there. Still they are existing. Okay? Now, next one, which comes under limiting octets only or incomplete octets only. Okay? So, in case of the incomplete octet only, our next examples will come. Okay? So, but they will be having odd electrons. They will be having odd electrons. See, for example, if I take nitrogen, so it can form some of the compound because nitrogen is having how many valence electron? 5 valence electron. Okay? So it's an odd number. 5 is an odd number. So nitrogen is having 5 valence electron. So this nitrogen, we have a molecule called as nitric oxide. We have a molecule called as nitric oxide. And this nitric oxide is also produced in our body. Please remember, nitric oxide is also produced inside our body. Anyway, we are not going to discuss that one. So that's where we have the nitric oxide. This is the structure, nitric oxide. Okay. Now if I observe this molecule, if I want to write the Lewis dot structure, can any one of you tell me what can be the Lewis dot structure? Naturally, 4 electrons are involved. So 1, 2, 3, 4. So 1, 2, 3, 4, 5. So that's where we have the Lewis dot structure for nitric oxide. That's where we have the Lewis dot structure for nitric oxide. Now if you observe it carefully, there is a presence of lone electron. There is a presence of lone electron. So therefore this molecule quite unstable but still existing. This molecule is quite unstable but still this molecule is existing. That's where there is a presence of lone electron. So how many electrons with nitrogen? 1, 2, 3, 4, 5, 6, 7. 7 electrons. And with respect to oxygen it is 8 electrons. With respect to oxygen it is 8 electrons. So that's where we have the nitric oxide. May be quite unstable, but still molecule will be produced. Molecule is existing in the nature. All of you have understood? Any doubt? So 7 electron, it is an odd electron, less than 8. Therefore, it also comes under incomplete octet only. Under that, it is with respect to odd electrons. It is with respect to odd electrons. Fine. Same way, we have nitrogen dioxide. We have another molecule, nitrogen dioxide. I am taking examples from your textbooks only. So NO2, nitrogen dioxide. Okay. So this oxide of nitrogen is also produced in the nature also. One of the reason for acid rain. Okay. So that's what NO2, which can later be converted into HNO3, nitric acid, which will cause the acid rain. Okay. So that's why this NO2 is existing in the nature, and it also comes under incomplete octet with odd electrons. Incomplete octet with odd electrons. Okay. Now, this is the structure of this particular molecule. Okay. Anyway, we are not interested in structure. We want to have the Lewis dot structure. Observe here carefully. So 1, 2, 3, 4. Okay. So 1, 2, another oxygen. Okay. So what is happening? What I have written here. Okay. Here 1 electron. Okay. What is happening here? If you observe here carefully, these two electrons, I will make it a bit dark so that all of you can see. Okay, so if you observe it carefully, what is happening? If you observe the right side oxygen, all the electrons of oxygen, valence electron of oxygen, they are present as it is. All the valence electron of right side oxygen, they are present as it is. All the 6 electrons are present. Right? So that's what I can see here. Or if you want to make it, I will make you understand by making different shape for nitrogen electron. So 1, 2, 3, 4, 5. So those electrons belongs to nitrogen, which I have circled. Those electrons belongs to nitrogen. Now what is the speciality? What is happening? So we can see here that one of the bond, single bond, it is formed where both the electrons are invested by the nitrogen. Yes, nitrogen is getting 7 electron, I understand. That's why it belongs to incomplete octet. But if you observe it carefully, another important character you can observe here is, in one of the bond, this single covalent bond, both the electron are invested by the nitrogen. Oxygen is not investing any of its electron. All the electrons, valence electrons of oxygen, they are present as it is. But nitrogen is the one which is putting 2 electrons for the covalent bond. All of you have understood? So this type of covalent bond is called as coordinate covalent bond. This type of covalent bond is called as coordinate covalent bond. Okay? So it is a covalent bond only. So hagadre what do you mean by coordinate covalent bond? Coordinate covalent bond means any one element will invest the electrons for the bond formation. That's where we have the covalent bond. It's not completely donating its electron to oxygen, no. Okay, but it is investing that electron for the bond formation. Don't get confused. Okay, so still those 2 electrons, they are present in the shell of nitrogen only. All that is shared by the oxygen. Nitrogen has not donated the complete its electron to oxygen, no. So that's why it is called as coordinate covalent bond. So what do you mean by coordinate covalent bond? It is the covalent bond where electrons will be invested by any one element. So that condition is called as coordinate covalent bond. All of you have understood? Any doubts? Okay, more I will repeat. So observe here carefully. Whatever electrons belongs to nitrogen, I have made it as a circle. Whatever electrons of oxygen, they are present as a dots. Just to make you understand what is the exact bonding is happening. Okay? Now, what will happen here is, if you observe, this nitrogen has invested both of its electrons. 1, 2, 3, 4, 5. So total valence electron of nitrogen is 5. So that's how it has been distributed. Now in that 2 electron has been invested for the making single bond between nitrogen and oxygen, and those 2 electrons, because all of us we know that single covalent bond will be having 2 electrons involved, and both those 2 electrons are taken care by nitrogen. Oxygen is not putting any electron. 1, 2, 3, 4, 5, 6. All the 6 valence electron of oxygen, they are present as it is. So nitrogen dioxide is a coordinate covalent bond. Yes, there will be formation of lone pair and shared pair electron. No sir. That's what Rohan. So this is what it will happen. The only lone electron will be present on the nitrogen. No lone pair because total 5. So 1, 2, 3, 4, 5. If that is the reverse case will happen. Say for example, okay, this does not exist, but to make you understand I am writing to avoid the confusion. Okay, so we will imagine nitrogen has invested only one electron. Okay, now oxygen will have the lone electron. Oxygen will have the lone electron. All of you will agree? Second case does not happen. By chance, if it happens, then also lone electron will be left over on oxygen. And oxygen is more electronegative compared to nitrogen. All of you are understanding? Listen to me carefully. Second case, it will not happen. Second case, it will not happen. Saurabh. No. It's not for JE. It may help you for your JE exam, but this is for board only. Okay, it's for board only. Fine, but it will be helpful for your competitive exams, no doubt. But it is for your board exam. Okay, so try to understand the concept. So this is the one. Actual Lewis dot structure of nitrogen dioxide is this is the one. Okay, fine. But even in second case, if you think that, so why the hell nitrogen should take the lone electron? In that case, second case, then oxygen will have the lone electron. And all of us we know that oxygen is a boss. Oxygen is more electronegative compared to nitrogen. So when boss is there, assistant cannot argue. They have to just listen to the boss. So therefore, oxygen will tell, I am not going to put any electrons. I don't want to have lone electron with me. So therefore, nitrogen will tell, yes sir, I will put my electron. So that's where nitrogen dioxide is existing in the nature. All of you have understood? Now if you observe it carefully, now that's where oxygen 8 electron, but nitrogen is with 7 electron. Nitrogen is with 7 electron. Still this molecule is existing. Still this molecule is existing in the nature. All of you have understood? Fine. So that's where we have the coordinate bond. That's where we have the coordinate covalent bond. Should not the symbols for atoms be different for two elements, sir? I am not getting Rohan. Should not the symbols for atoms be different for two elements, sir? What do you mean by that? Naturally, symbol will be different. For nitrogen it is N and for oxygen it is O. But which one you are talking about? Symbol. Okay? So that's where we have the nitrogen dioxide. Now since nitrogen has invested extra electron, to be more accurate, since nitrogen has invested the extra electron, it will have the positivity. Since oxygen has gained the extra electron, it will have the negativity. But since equal amount of positive and negative is there, NO2 does not have any charge. Like circle for nitrogen and cross symbol for O. I am not getting cross symbol for O. What do you mean by that? Oh, you are talking about since nitrogen is a central atom, it should have this circle, and others they should have egg shape. That's what you are telling? It's all our representation, that's all. It's all our representation, that's all. That's where we have the Lewis dot structure. Fine? All of you have understood? So those dots. No. Dots, that's what. To make you understand, I have written different types of dots. Otherwise, you can write it with uniform one, all with dots only. To make you understand that nitrogen has invested the 2 electron, to make you understand, that's why I have made it as a circle. That is not required. Just you can put the dots, that's all. Just you can put the dots. So these things I have made you to understand, that's all. I have written that one to make you understand. It's not that for nitrogen different shape of electrons, for oxygen different shapes of electron, that is not required. Only dots you should write. Fine? All of you have understood? So therefore, if I want to talk about Lewis dot structure for nitrogen dioxide, then I should mention it as with dots. No different shapes, nothing. All of you have understood? So that's where we have the incomplete. That's where we have the incomplete octet. So that's where if I want to write, so I will make it as 1, 2, oxygen, 2, 3, 4, 5, 6. Okay? So 1, 2, 3, 4, oxygen, 1, 2, 3, 4. Here one electron will be left out. This is the Lewis dot structure for nitrogen dioxide. Okay? So those circles and all I have written to make you understand, that's all. All of you have understood what you mean by coordinate covalent bond? Okay? So any doubts? Maurya, whether I have reached you? Have you understood what I have told? All of you have understood? If you have any doubts, you can ask. And very important point here is, this is for your board exam only. It's there in your syllabus, but still, if you understand all these things properly, definitely for your competitive exams, it's going to help you out. Okay, it's going to help you out, no doubt. Okay? Okay, Maurya. Yes, then in that case, we will move to the last one. With respect to limitations for octet rule only, we will move to the last one. Okay? So we have discussed about limitations of octet rule. We have discussed about incomplete octet with even electrons and odd electrons. With even electrons, we have gone with lithium chloride, boron trichloride, hydrogen. They are all the example for incomplete octet with even electrons. Just now we have discussed about nitric oxide and nitrogen dioxide, which talks about incomplete octet with respect to odd electrons. So coordinate covalent bond are not in the stable form. No, Shuchita, they are stable. You are asking the question, right? Yes, coordinate covalent bonds are also stable because they are covalent bonds only. They are equally energetic or equally potent as that of the covalent bond. Okay, only thing is there are different types of covalent bond. They are also stable. There are many molecules which are present with coordinate covalent bond. There are many molecules which exist with coordinate covalent bond. Shichita, whether I am clear? Okay. So what we have discussed here is limitations. Now last one, that is with respect to expanded octet. Naturally, when I am talking about expanded octet, it should be dealing with those molecules where more than 8 electrons are present. Okay, it is with respect to those elements where more than 8 electrons will be present. This is the condition where more than 8 electrons will be present. So that's where we have the expanded octet. Fine. Very important example here it can be PCl5. We can take the example of phosphorus pentachloride. Okay, so PCl5. Now, can you tell me what is the total valence electron of phosphorus? What is the total valence electron present in the phosphorus? Any one of you? Just give me the number. What is the total number of valence electrons present in the phosphorus? Yes, Shuchita, very good. Phosphorus is group 15 element. It is next to the nitrogen down. It is down to the nitrogen. So naturally it should have the 5 valence electron. All of you are correct. Very good. So therefore 1, 2, 3, 4 and 5. Okay. So total 5 valence electron. Since they are involved in bonding, I have made it separate. That's all. Now one will be making interaction with one chlorine. Okay. So another is making interaction with, another is going to make interaction with another chlorine. Okay. So another chlorine. Okay. Now here another chlorine will be there. I want to be uniform. So another chlorine. Okay. So here another chlorine. And here another chlorine. Here another chlorine. So or to be more this one, we have steric freedom. I will make it this chlorine bit fast. Okay. Now if I want to write the Lewis dot structure, that means this is for the phosphorus. Okay. So this is for one chlorine, this is for another chlorine, this is for another chlorine, this is for another chlorine, and this is for another chlorine. Okay. So that's where I have the Lewis dot structure for PCl5. Very stable molecule. Hagadre, what is the total electrons after the bond formation with respect to phosphorus? What is the total number of electron with phosphorus in its valence shell? Any one of you? Just tell me the number. What is the total valence electron with phosphorus? In PCl5, what is the total number of valence electron with respect to phosphorus? Chidwan is telling 10. Suchita, she is telling 8. Which one I should go with then? 10 or 8? Yes, Suchita, now you have made yourself correct. Yes, absolutely right. It should be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So phosphorus is going with 10 electrons. Okay. Now chlorine, all the chlorine with 8 electrons, no doubt. All the chlorine with 8 electrons. Fine. But what about phosphorus? They are coming with 10 electrons. Molecule is existing. Where it is more than 8 electrons, still the molecule is existing. That's why it is an example for expanded octet. It's an example for expanded octet. Fine. All of you have understood? Same way, we have sulfur hexafluoride, then we have sulfuric acid. Many other examples are there which will have more than 8 electrons. An element in that compound will have more than 8 electrons. And still that molecule is existing in the nature. So that's where we have the limitations for octet rule. That's where we have the limitations for octet rule. Fine. That's where we have the limitations for octet rule. So you will go with expanded octet, even sulfuric acid. Sulfuric acid can also be an example where sulfur will have more than 8 electrons. Sulfur hexafluoride where sulfur will have more than 8 electrons. So all these are the examples for limitations of octet rule. Okay, limitations of octet rule. Any doubts? Any doubts you have? So in that case, so what we have discussed here is, to avoid the confusion, I will explain it once again. In case of the limitations of octet rule, okay, octet rule, first thing we have gone with limiting, not limiting, exact, incomplete. Limiting only is coming. So it should be incomplete octet. Okay? So those compounds which are having less than 8 electrons. Elements will have less than 8 electrons. So that comes under this category. In that we have discussed about even number. Okay? So in that we have discussed about boron trichloride, lithium chloride, then we have discussed about hydrogen gas, etc. etc. That's why we have incomplete octet where less than 8 electrons in any one element or both the element, and that's why it can be even number category where we have BCl3, lithium chloride, hydrogen, where boron will have 6 electrons, that is even number. In this molecule boron will have the 6 electron, lithium will have the 2 electron, and both the hydrogen will have the 2 electrons. But chlorine will have 8 electrons, no doubt, but boron 6 electron, lithium 2 electron, and even hydrogen will be with 2 electron, each hydrogen. So even number. Then we have discussed about odd number, incomplete octet only. Then we have discussed about odd number, less than 8 electrons only, but odd number, that is nitric oxide, nitrogen dioxide are some of the example where nitrogen will have 7 electron. No doubt that oxygens will have 8 electrons, but nitrogens they are having 7 electrons. Example for incomplete octet, even number, odd number. Then we have discussed about expanded octet. Just now we have discussed about expanded octet. So in that case it will be more than 8 electrons. More than 8 electrons, but still molecules are existing. Examples can be PCl5, H2SO4, even sulfur hexafluoride. So they are all the examples for expanded octet. They are all the examples for expanded octet. Say for example here, phosphorus is having how many electron? 10 electron. Here sulfur will have 12 electrons. Here sulfur hexafluoride, where sulfur, once again 12 electrons. So that's where it will be more electrons, more than 8 electrons. Okay, all of you have understood? Any doubts? Any doubts in this? This is what we have discussed today. Any doubts? Okay. So please remember the examples. Fine. And anyway, sulfuric acid structure and all you are going to have in second year, where they will be asking the question to write the structure of sulfuric acid and all. But Lewis dot structure this year. Okay. Fine. So by this I will stop today's class. I think we are going to meet after 1 week. So please practice with some more examples from your check sheet or textbook, NCERT textbook. Okay, whatever or whichever topics are done, that is hardly 3 topics are done completely, and chemical bonding a bit has been done. So try to go through all these chapters once again and solve some competitive exams questions. Okay, so you have enough time. 1 week time is there. No online class, nothing. Fine. So I will stop here. Any doubts? Yes, in that case, we will meet after 1 week. Enjoy the holidays. Don't forget me. Happy Dasra. Yes, Kritik. Happy Dasra to everyone. Bye. Okay, bye. Take care. Be careful. Wear the mask and then only go outside. Okay? Enjoy. Take care. At the same time, you should take care also. Yes. Thank you. Wish you all happy Dasra. Okay, bye.